Interfaces and inner classes. Introduction. In this chapter, we will discuss the following topics: interfaces, object cloning, interfaces and callbacks, and inner classes. Interfaces. An interface is not a class, but a set of requirements for the classes that want to conform to the interface in the Java programming language. All methods of an interface are automatically public. Interfaces never have instance fields, and the methods are never implemented in the interface. Supplying instance fields and method implementation is the job for the classes that implement the interfaces. To make a class implement an interface, you carry out two steps. You declare that your class intends to implement the given interface. You supply definitions for all methods in the interface. To declare that a class implements an interface, use the implements keyword. Class employee implements comparable. In the below given program, the employee class implements the interface comparable, and compare_to method is used to compare the employee salary. Properties of interfaces. Interfaces are not classes. That is, you can never use the new operator to instantiate an interface. Declare interface variables as comparable x. OK. An interface variable must refer to an object of a class that implements the interface. X equal to new employee of. You can use instance of to check whether an object implements an interface. If an object instance of comparable. Interfaces and abstract classes. There is a major problem with using an abstract base class to express a generic property. A class can only extend a single class, but each class can implement as many interfaces as it likes. Object cloning. The clone method saves the extra processing task for creating the exact copy of an object. If we perform it by using the new keyword, it will take a lot of processing to be performed. That is why we use object cloning. The clone method is a protected method of object, which means that your code cannot simply call it student s1 equal to new student of 101, Amit, student s2 equal to student s1 dot clone of. For every class, you need to decide whether the default clone method is good enough. The default clone method can be patched up by calling clone on the mutable sub-objects. Clone should not be attempted. Third option is actually the default. To choose either the first or the second option, a class must implement the clonable interface and redefine the clone method with the public access modifier. The following program clones an instance of the class student. Initially, we can create an object for the class student, and then we can use clone method to create cloning for the same value. In here, the roll number and name of the student has been cloned using the clone method. Interfaces and callback. The callback pattern is a common pattern in programming. You need to specify the action that should occur whenever a particular event happens in this pattern. There is an interface named callback is declared. Through the caller class object, the register method has been called and it will notify the method to callback method, which is declared in the callback implementation class. In the below given program, we have implemented the interface callback and declare the method to callback. and its definition is given in the callback implementation class. Next, we have created the caller class and created object for caller class and callback class. Then we have called the register method to register the callback. After calling the register method, then we can call the method to callback to print I have been called back. Inner classes. An inner class is a class that is defined inside another class. There are three reasons. Inner class methods can access the data from the scope in which they are defined, including the data that would otherwise be private. Inner classes can be hidden from other classes in the same package. Anonymous inner classes are handy when you want to define callback without writing a lot of code. In the below given program, the inner classes declared inside the outer class. We have created an object for the outer class. With that object, display method is invoked. Inside the outer class, we have created object for inner class and invoke the show method, which is defined inside the inner class. The nesting is a relationship between classes but not objects. An object that comes from an inner class has an implicit reference to the outer class object that instantiated it. Through this pointer, it gains access to the total state of the outer object. Static inner classes do not have this added pointer. Example of inner class inside a method. The syntax for inner classes is rather complex. In the below example, we have declared the inner class inside the display method. Local inner classes. Local classes are never declared with an access specifier, that is public or private. Their scope is always restricted to the block in which they are declared. They are completely hidden from the outside world. It is one of the great advantages of using the local classes. The below given program is an example of local inner classes. Local is the class which is declared inside the local inner class. In here, the variable data is declared as private and it is accessible inside the local class also. Anonymous inner classes. If you want to make only a single object of this class, you don't even need to give the class a name. Such a class is called an anonymous inner class. Here eatable is an interface, then the inner class implements that interface. An anonymous inner class cannot have constructors because the name of a constructor must be same as the name of a class and the class has no name. On the other hand, the construction parameters are given to the superclass constructor. Static inner classes. You can suppress the generation of that reference by declaring the inner class static. If you want to use an inner class simply to hide one class inside another, but you don't need the inner class to have a reference to the outer class object. A normal inner class has a connection between its objects and the outer class object that created the inner class object. This allows an inner class definition to reference an instance variable or invoke a method of the outer class. There are certain situations, however, where an inner class must be static. If an object of the inner class is created within a static method of the outer class. If the inner class must have static members, Since a static inner class has no connection to an object of the outer class within an inner class method, instance variables of the outer class cannot be referenced. Non-static methods of the outer class cannot be invoked. To invoke a static method or to name a static variable of a static inner class within the outer class, preface each with the name of the inner class and a dot.